Starting now. Welcome to the AI Mentors podcast. I'm your host, Mark Kelly, Chief Customer Officer at Alldus International. On today's show, we have Sanji Fernando, SVP, Artificial Intelligence Analytics Platform at Optum. Sanji, very good to speak to you today.
Yeah, nice to speak to you as well.
Sanji, for people that don't know Optum, could you give us a little bit of an overview about the company?
Yeah, sure. We are a very diversified health services business. And while our brand is not well known, our sister company, United Healthcare, is a little more widely known. United Healthcare is one of the largest private insurers in the US today. And so United Healthcare and Optum together make up the United Health Group. At Optum, we focus on almost every facet of the US healthcare system. Our customers include large and small employers, individuals directly, hospital systems, other insurers, the state governments, federal governments, including CMS, and even pharmaceutical companies. So you can imagine that's almost everyone that sort of plays in the US healthcare system. Our biggest businesses are, we do a pharmacy benefit business. We're one of the largest in the US. We have Optum Care, which is now becoming one of the largest networks of primary care providers in the US. I think today Optum employs more physicians than anyone in the US. And that's been a key part of our strategy to deliver great value and care to folks across the US. And then Optum Insight, where I'm at, which is our data analytics and services business, where we support important administrative processes and consulting services to any number of healthcare clients.
Sanj, can you tell me a little bit about your background and how you came to now?
Yeah, so I studied computer science in college, worked primarily in technology most of my career. My last position was with Nokia, the cell phone manufacturer. And about 7 years ago, I had the opportunity to pursue a role at Optum. At Nokia, I had been focused on data science and starting some of the first data science teams there. And in 2014, when Optum, and specifically Optum Labs, our R&D center, approached me, healthcare was still starting to explore the impact of large data, big data sets. Back then everything was about Hadoop, HDFS, MapReduce. And so it was a great opportunity for me to parlay my technology background into a way to break into the healthcare industry, which even today for me, it's so complex and I'm learning something new every day. And so it was a great opportunity for me to get started here.
Sanji, so in the world of artificial intelligence, people can sometimes get fixated about the models, but can you tell us a little bit about getting the data fit for purpose and working on the right problems to impact?
Yeah, I think even before you get to data, because sometimes even myself, we could be enamored with large sets of data and what might be possible. But I think getting to the right problem statement is universally needed for any successful technology solution, let alone artificial intelligence. I think especially so with artificial intelligence because what you could do is amazing. We see papers and breakthroughs every day, and we see wonder in the software tools we use in our daily lives, whether it be a smart speaker or things that happen in our car, automated driving. And so you ask yourself, oh, what is possible? But I think once you get past that ideation, you've got to be very tight about what problem you're solving. And that should immediately direct you to what is the data that you need. And what's the data that you may not have to solve that problem? Early on in our explorations, we read great papers about imaging. This is like 4 years ago, and how radiological images could be classified by a convolutional neural network. And there's a lot of interest to say, hey, why don't we train our own model to do that? But two things we ran into. We don't operate a lot of imaging facilities in the US, at least at that time. So we weren't really solving a real problem at Optum. And then secondarily, or directly correlated to that, is we didn't have a lot of imagery data that was in a place or collected in a way that we could do large scale training. So nailing the problem is first, and then quickly assessing whether you have the right data to understand and provide an inference against that problem is a close second.
I think it's a real challenge to do that because people want to get started, get working on the problem, and just start to make headway. And I always think of the Abraham Lincoln quote where he said, if I had 8 hours to cut a tree, I'd spend 7 hours sharpening my blade. And the reality is that you can fall down rabbit holes so quickly working on different types of problems that if you don't stay tight to the North Star, everybody can quickly get, I suppose, really bogged down in it and also get very disruptive if it doesn't necessarily go to plan. And with research, that's something that can happen particularly easy as well.
I think that's absolutely right, and it's a great analogy because we do spend a lot of time, quote unquote planning, but really setting ourselves up around that problem, defining it rigorously, understanding how we might solve it. And then we use, which I think is becoming very common, a very experiment focused approach to test and validate whether or not our solution is actually meeting the criteria to solve that problem. You're absolutely right. We can get enamored with the real elegance and performance of some of the latest breakthroughs in artificial intelligence. But one thing we do, and I think this is becoming more common practice, is that we'll start with a baseline almost, thinking of the problem very simplistically and saying, what does our inference look like if we just use like regression or something more interpretable, easier to maintain, easier to understand? Because if we can't exceed that sort of floor with an order of magnitude improvement, maybe we're trying to use too complex a tool to solve a very straightforward problem.
And as engineers, we can all be guilty of over-engineering problems.
Yes, I mean, we love the latest. I'm enamored with what I read and what I learn about OpenAI's GPT-3, and I'm sure it'll have immense impacts all over our industry and the future. But today, it's really just a very interesting, fascinating engineering feat, but maybe not tied directly to things that we can implement in production today.
Yeah, one of our recent virtual meetups, we had a gentleman from Professor Paul Walsh from Accenture, and he said we did a Kaggle competition, and the rules-based system was the best approach, but there were so many dirty looks in terms of, why can't we throw a CNN at it, or, versus rules-based. And in the world of AI, if you start talking about if-then rules-based systems, people can think you're selling them snake oil, and it's quite interesting. You have to be very careful on the journey that you go on, and determining what you use and why you use it are you have to be a case of point. And tell me a little bit about the data, because in healthcare you've got so many different diverse data sets, and the journey to getting that correct and then getting into production, it's not necessarily a straightforward plan, and a lot of companies find it challenging.
Yeah, it is, and I think on top of that, I think when we see and hear and read other industries driving new inference through training models on images or conversations, it's pretty exciting. But But at Optum, we have worked with healthcare data for decades, maybe 20, upwards of 30 years. Analytics have played an incredibly important role in delivering valuable healthcare for 30 odd years. And so we have a lot of history and lineage in how we manage and support our customers and their data. And we have a great stewardship around this because we have to. We've got regulatory frameworks like HIPAA that require us to be much more thoughtful in how we use data, when can we use it, when can we use it appropriately, either to analyze or to train new models. And all that's been in place for decades at Optum. And that's incredibly important. It may take time for us to articulate how we plan to use the data. Do we have the appropriate rights and oversight to use that data? Are we designing an inference that meets our guidelines for responsible use of AI? All those come into play before we even actually look or touch at the data. And I think that's incredibly important to be successful in AI in healthcare, but also meet the responsibilities of managing and supporting that data in a healthcare environment.
It's a really, really good foundation to have. And, we come across companies who don't necessarily have that foundation or framework to work towards. And then at the end, there's a lot of holes in their approach. Monitoring and reflection and reviewing. Tell me about some of these things that you do with models.
Yeah, I think if we think about the model development process, design and training of a model, I'll refer to mainly the machine learning side of things. Once we get past some of that experimentation and say we are able to identify a trained model that meets all the needs of the business problem that we're trying to solve, we often say that's the starting line, not the finish line. We know that once we deploy these models in production, especially some of the neural networks, they're necessarily going to improve with more data. And so it's important for us to understand how that model is performing, understand how it might perform if we train it with new data that's being presented to it, understand if the data that is being presented is changing or drifting, and if that has a substantial effect either in model performance or output. And then also, what's been incredibly important for us is to understand, starting in that development cycle, what is the distribution of outputs of the model, and do we understand if there's a question of fairness in the model based on how the outputs might be distributed across different protected classes? So all those become incredibly important steps to being successful in not just deploying a model, but maintaining inference over time.
Yeah, because sometimes people can get very fixated about deploying the model, but then it's actually the journey of monitoring it as well.
Mm-hmm.
Sanji Fernando, thank you very much for your time today. I really appreciate it. You've been listening to the AI Mentors podcast. I'm your host, Mark Kelly, Chief Customer Officer at Alldus International. And our guest today has been Sanji Fernando, SVP Artificial Intelligence at Optum. Thank you very much for your time today.
Thank you.